Picking up where we left off at, it says, why does it not make sense to talk about our model's y-intercept? Now, our y-intercept was 0, negative 1700. So this is saying that at 0 weeks, the baby weighs negative 1700 grams, which we know is impossible. That's why this model doesn't make sense. I mean, the y-intercept of this model doesn't make sense. Okay, now we go to E. How much time does our model predict a child would weigh if it was born at week 38? Find this both algebraically and with the table feature on your calculator. So algebraically, we would take the y equals 100 x minus 1700, and we'll substitute in 38 for the x. So we have y equals 3800 minus 1700, which will leave us 2100 grams. So that's how you would solve it algebraically. Now, as far as your calculator is concerned, you have to hit your y equals key, clear out all these values, and type in the equation. The equation is 100x minus 1700. And then you would press second and graph, and you would get the table. You would go up to, well, first of all, I need to change one thing here. Let's go here to the table. Okay, we would need to go to 38, and it gives you 2100. Okay, now it says here, at what gestational age will a typical human child have a birth weight of 2.652 pounds? Find this both algebraically and with the table feature on your calculator. Now, first of all, we have to change pounds to grams. So it'll take 2.652 pounds. So it'll be 1,000 grams. It's the same as 2.2 pounds. And that'll give us 2,652 over 2.2, which will give us 1,205.5. And this is grams, because you know pounds will simplify out with pounds. And so now we have to find x. So we will have the total amount, which is 1,205.5 grams, is equal to 100x minus 1,700. So we add 1,700 on both sides. So it'll be 2,905.5 grams is equal to 100x. We divide each side by 100. Then our final answer would be 229.055 is equal to x. Now we know that this represents weeks, so this would be approximately 29 weeks. And that will be our final answer. Now, scroll on down here. It says, what birth weight does our model predict for a child born at week 96? So we have y is equal to 100 times 96 minus 1,700. So we have y equals 9,600 minus 1,700. And then y will equal to 7,900 grams. Now with H, though the prediction made in part G is mathematically accurate, why would we discount it as practically meaningful? And the reason being is we know that 96 weeks is close to 2 years. we know no woman stays pregnant that long. So that's why we would dismiss that. Okay, now we go to the back here. We have example 2. Though you won't earn any interest, you decide to create a savings account and deposit money into it every week and never withdraw from it. The account starts off with a balance of $480 and you deposit $25 per week. Find a linear model for these data and predict when your account will have a balance of $10,000, enough for a down payment on a house. Okay, so now we look at this. It's increasing. According to the model, it's increasing by $25 per week. And we know we know is our slope, which is our M. Now, so we know M is 25. Now our beginning balance is equal to our y-intercept, which we know is our B, which is equal to $480. So now we have our slope, and we can write that as an ordered pair, 0, 480. So now we have our slope, we have our y-intercept, so now we have our equation. Y is equal to 25x plus 480. Now, we want to know when this will get up to $10,000. So our y would be 10,000 is equal to 25x plus 480. So we'll subtract 480 on both sides. So it'll be 9,520 is equal to 25x. We divide each side by 25. And that would give us 380.8 is equal to x. So this would be approximately 381 weeks it would take for us to get $10,000. And that is it.